Okay, so in this lesson we will be focusing on the NC part programming, and we're going to take a look at different kinds of G codes and learn what those commands are. And so let's get started with the NC part programming, the overview. So the numerical control program is a language in which operators tell the CNC controller how to carry a machining task, um, as what it's done in the conventional machines by the operator. Um, the NC program is also referred to as G codes or M codes, or the combination of both the G and M codes, because of the fact that most of the NC programs are having these G codes. Okay, and so the G codes are basically for the machine instructions, so where the cutter should move, or how fast it should move, or what path that it should take. And the M codes are typically used for providing the auxiliary instructions. For example, turn the spindle on or off, or turn the coolants on or off, and so on. All right, so most of the CNC machines typically have a vocabulary of over 100 words, but basically only 30 or so are used in the practical applications. So we're going to learn what these the most commonly used G codes and M codes are, and then we'll be taking a look at some of the programs that can be written. All right, so in NC machines, the tool paths and the motions are controlled by the MCU, that is called as the machine control unit. And MCU consists of two parts. One is the data processing unit, DPU, and the other one is the CLU, which is the control logic unit. Okay, the DPU reads the NC program and it decodes this program statements and passes it on to the LCU. And this information includes positions of each axis of the machine, what is the direction of motion, the feed rate, the auxiliary function control signals, for example, the coolants, if it is on or off, and all that. The CLU receives this data from the MCU, or rather, the CLU receives this data from the DPU and then converts them into control signals and controls the machine by the actuation devices that replaces, typically the hand wheel, which you see it on the conventional machines. An actuation device can be a servo motor, or an hydraulic actuator, or even a step motor. Okay, the servo motor is basically an electromechanical device in which an electrical input determines the position of the armature of the motor. And you might have seen these servos, which are used extensively in robotics and also in the radio controlled cars, or even on the airplanes and the boats, and so on. Okay, so this MCU gives the instructions to the servo system, monitors its position and velocity output of the system, and uses this feedback to compensate for the errors between the program command and the system response. And this is basically what is called as the feedback, or the closed loop control. Okay, the axis of the motion is equipped with the actuator device, and basically there are three primary axes, X, Y, and Z, that forms the machine tool coordinate system. The idea is that the machine tools are always required to be given the inputs in terms of the X, Y, and Z coordinates. So it's very important to know what are these axes that are typically used in this machining equipment. And so the Z axis is the most important axis for machining. This axis is always aligned with the spindle that imparts the power. Okay, and so that's basically as decided as the Z axis will be the axis for that particular direction, that is aligned with the spindle which imparts the power. For example, if you look at here on this graph, on this image, on a milling or a drilling machine, the X-axis will point to the right when a operator is facing the machine. Okay, and y-axis is basically determined by the x-axis and the z-axis through a right-hand rule. Okay, so if the operator is standing here, the x-axis would be to the right side, the positive x-axis to be on the right side. As you saw in the previous slide, the z direction is the direction where the spindle is imparting the power, so that's the z-axis, the positive z in the upward direction. And then based on that, the y direction can be figured out using the right-hand thumb rule. Okay, so if the thumb is pointing towards the x-axis direction, then the z-axis one direction is up, in the upward direction, which is the z direction, and then obviously the y direction can be found out from that. And on the stock rotating machine, so here the stock is basically rotating on the spindle, so obviously that becomes its z direction, and then the x-axis points to the direction of the tool moment. So that's the tool moment is going along the this transverse direction with respect to the z-axis, and the motion along its positive direction moves the tool away from the stock. Okay, so those are the directions as are decided for these machines. All right, so now let's take a look at the NC words and the NC blocks. The NC programs list instructions to be performed in the order they are written. Okay, so you have to be very careful as what is the sequence of the machining processes that you want to achieve for a particular part. Each sentence in the NC program is written on a separate line, and that is called as a block. And the block is basically a group of NC words which are terminated by the end of the block character. So for example, a sample NC block is shown here. So N100 is basically the NC word that is the sequence number beginning of this block. So that's just a sequence number. It could be N10, N20, N30, N40 or something like that. So if you have 10 lines in your code, then you can start with N10, N20, N30 up to N100 and so on. Then you have the G01, which is the G01 and G41, which are the preparatory functions. And then you have the dimension words, which are basically X and Y, the coordinates. And so these X and Y commands specify the cutter location, which locate the center point of the bottom face of the end mill, or basically the tip of the drill bit. All right. And then you also have the feed rate, which indicates as F5.0, and then some of the miscellaneous functions, which are the M chords. So that's a typical example of a NC program block that you can find it in the CNC machines. And if you now take a look at some of the the NC words, or basically what are the different alphabets. So this NC word starts with an alphabet code, as you saw in the previous slide, the N or the G or the M or the F, and so on. So these G codes and the M codes are very frequently used, and therefore sometimes the NC programs are also called as either G codes or M codes and so on. And so these are some of the examples of what all the different types of alphabets which are used in the codes, and you can basically read it by yourself. Just going to go over very briefly the important ones, which basically F, which is the feed rate function, G is the preparatory command, these are the machine codes, H stands for the tool length offset number, then you have some of the arc centers for X, Y, and Z axis for I, J, K. These are used when you want to move the tool in the circulatory motion. Then also you have the M codes, which are the special auxiliary functions, like the spindle or the coolants on and off. N stands for the block number or the sequence number. O is the program number, and so on. So you can again read through all these different alphabet codes. The idea is that you should be familiar with the NC programming different codes. Obviously, when you're making a solid model, the program is going to write the codes, automatically generated, and then you can feed that into the CNC machine. But there are always some sort of adjustments that you need to do it, and you can't just simply take the code generated by the CAD model and just feed it into the CNC machine. There are always some adjustments which are required when you're trying to fabricate the part. Some of the G codes, commonly used G codes, like I said, there are more over 100 the G codes available, but most commonly used ones are basically listed here. And we're going to take a look at some of these G codes one by one in the next video. But just to have a brief outline or a brief idea about these G codes, the G00 is basically just a rapid motion, point-to-point positioning, and it's a non-cutting operation. Okay, so when you try to use this command or this code G00, it means that you're just trying to move the tool from one location to the new location with whatever the coordinate system that that you have provided, and it's basically not cutting, so the tool is lifted over the surface that needs to be machined. Basically this is just used to locate the tool at the right place or the right location where you want to start cutting, which is done with this command G01 if it's a linear motion, or G02 if it's a circular motion, and it's clockwise. So if it's counterclockwise, then you need to use the command G03 for the circulatory cutting motion of the tool. G04 is basically the dwelling. G12, G13 are the circular pockets that you use in the milling machine, based on if it's it's clockwise or counterclockwise. Accordingly, you have to use these codes. 17, 18, 19 are basically the planes that you want to select for doing the machining operation. 20 and 21 are for the units, which are inches in the metric. Accordingly, you have to use those accurate codes. G28 basically returns to the home position, or it's also called as the machine zero or the machine reference point, from where you typically begin the machining operation. And then again, G30 is returned to the secondary home position. You may have more than one reference points in the system, depending on how complicated the part that is. Then 40, 41 and 42 are basically the cutter radius compensations, either from the left or the right, for 41 and 42. And G43 is the tool length compensation. All the tools are coming in the different lengths, and so you need to do a tool length compensation. So this also we're going to take a look at in the next video. All right, so some of these other G codes that you can just take a look at, and once you start writing or get more familiar with all these G codes, then you will start remembering the functionalities of all these different G codes. And then similar to this, there are M codes as well, which are auxiliary functions. For example, M00 is compulsory program stop, M01 is the optional stop, M02 is the end of the program, 3 and 4 are basically spindle on, and there are different attributes to that as well. M05 is stopping the spindle. Automatic tool change is M06, then the coolant options for the next set of M commands, and so on. So depending on how the program or depending on how the part needs to be machined, you can basically make use of these G codes and M codes. All right, so in the next video we will take a look at some of these G codes more carefully, and after that we will be able to write some sample programs for machining the components. All right, and that's it for this video. I'll see you in the next video then.